Hi, good morning. Yesterday, I was teaching you one question and it was so complicated. So, it's better to make a video and then you can understand this question very well. So, our lecture was logistic differential equation. I told you this equation, right? The equation is this one. What is this one? Dy by dt equal to ky in bracket 1 minus y by L, where k and L are the positive constant. Okay. So now we have this equation, this one, differential equation, and we have to solve this one. Okay. So first of all, what we have to do, this one, as you can see, y minus y by L. So y minus y by L, for example, I have y minus y by L. So I just take LCM and it can be written as L minus y. Okay. So this is L minus y divided by L. That's why I have written here in the second steps. In the second steps, I have only write down this one, L minus y divided by L. And now I have divided this given equation by, on both sides, y L minus y divided by L, as you see here, y L minus y divided by L. And after then, you can cancel this one, see, and the y cancel. So on the right side you have k only, and then on the left side we have dy by dt and the same things, y in bracket Ly by L. So I think that you understand here everything. After then, what I did, okay, and after then what I did, I just multiplied dt on both sides. I did nothing, I just multiplied by dt on both sides. So this dt and this dt cancel with each other. So after then, what we have in the second steps, the same thing, copy and paste dy k dt. And as you know very well, this L will go up and it will become L divided by 1 L divided by y L minus y dy, and here the same thing, k dt. So now I have this equation, see, L divided by y L minus y dy equal to k dt, and I have to solve this value. So I just write down the integration on both sides. As we did the integration on both sides, you will see that I have this equation. I did nothing, I just make an integration on both sides, this side and this side. So dear, the problem is now this equation, or you can say this functions contains a partial fraction, and I can solve this one only by partial fraction, as I told you in the previous week. Now I have this one, and I have to solve this integration first. So what I did, as I see that we have in the denominator y and L minus y, we have two factors and that is not repeated. So we will use the first concept in partial fraction that I explain you. Okay. After then, what I did, as you know, Okay, so now what I did, I just assume A divided by Y and B divided by L minus Y. And after then I will take the LCM as we did it before, and this one are cancel. After then I have L, and here on the right side we have AL minus Y in bracket plus BY. Now what is our purpose? What is our aim? We have to find the value of these two constants A and B. So I use my mind and I think that what I did here so that we can find A and B. So I use one mind and I put L equal to Y. When we put L equal to Y, we will see that the value of A becomes 0, L equal to Y, and I am going to put this value in this equation. So what is the value of L? Nothing, just put it L, here A, and then L minus, in the place of Y just write down L, plus B, and in the place of Y, L. Okay. Now as you see, L minus L equal to 0, so it means the whole term, this one, it becomes 0. So we have L and here is BL. So as you can say LL, we will divide this equation by L and the value of the B is 1. So we find out the value of B. In the same way, I have to find the value of A. So again, in this equation, I put y equal to 0, y equal to 0, so that value of B becomes 0 and I can find the value of A in easy way. So again in the same equation, I take this one and I put in the place of y 0, see. So B multiplied by 0, answer is 0. So I have L equal to AL. Then again this equation is divided by L, we can find the value of A equal to 1. So now we have A and we have B, and I will put this value in equation 2. Go to equation 2 and put the value of A and B here. This was A and this was B, and both the value of A and the value of B is 1. So I put in the place of A and B 1. So the equation become this one, L divided by Y, L minus Y equal to 1 by Y plus 1 by L minus Y. And I have to find the integration of this function, so you can integrate on both sides. Make the symbol of integration, this one on both sides, and then we can find it. As you know very well that this is, I told you in the classes, 1 by y dy can be written as ln y, and in the same way integration of 1 L minus y, that is minus ln L minus y. So I find out the value of this one. This is equal to ln y minus ln L minus y. Okay. Now putting this value in equation number 1. See. So now you can see this is my equation and I put this value, see, ln y minus ln L minus y. In the place of integration, L divided by y, L minus y dy. And here k is the constant, and integration of the constant is k t plus c. Okay, c is the constant also. So what I did there, I just write down the first term. See, I just write down first here and then this one. So this is the minus and this is positive, and then the copy and paste. And here I took minus as a common, So when we will take minus as a common, inside the bracket the sign will be changed. So it was positive, it becomes negative now, because I have taken minus as a common. This is equal to Kt plus C, and there is a one formula in log, that log m minus log n can be written as log m by n. Okay. Okay. So we can write this one minus, and ln, this is log m minus log n, I can write m by n, L minus y divided by y, that is equal to Kt plus C. Now this is the minus, we have this one, you see, this is minus. So as you see, this is minus, so I will multiply it by minus on the both sides so that it become positive. So I can write this positive and this become negative and this become negative. Okay. And now what we have to do, we have to find the value of y, removing L, removing ln. Okay. So there is only one concept, that you just make a base e on both sides. Just make a base e on the both side. You will find, I just write down both side e. Okay, and the same function I will put it here, and this will work in the exponent. Okay, and I told you very important formula, that if you have e and you have fx, sorry, if you have e and here is ln x, e ln x, the answer will be always x. Or you can say if you have e ln fx, any function, so this will be cancelled, the answer will be your fx. This is the formula. Okay. Okay. See, so I have written the base e on the both side and just copy and paste. So as you see, this is e and this is log. So e and in exponent log, and this is your function. So I think that this will be cancelled. So when it will be cancelled, you have L minus y divided by y, and here the same thing, copy and paste, only put it. Okay. So as you can see, this is L minus y, this is L minus y by y, and I have written here e, and the power is minus Kt minus C. As we know in indices, that when the base is same, then the power is added. I just break this one. I just write down, individually I solve e power minus Kt multiplied by e power minus C. Okay, and look, e is the constant and C is also a constant. It means the whole value is the constant. I assume that this is equal to b. B is also a constant. So in the place of e, the power is C, I will write b. Okay, so now here in the place of this one, I just write down b, and the same I just write down this one here. Okay, and this side, as you can see, okay, so just write down L minus y divided by y, and here b e power minus Kt. Now cross multiplication, this y will go this side, it becomes by e power minus Kt, and here is L minus y. So this minus y go this side, it becomes positive. So what we have this one equal to L. Okay, just change the location only. by e power minus kt plus y equal to L. And as you can see that here is y, we can take y as a common. So as we take y as a common inside the bracket, we have b e power minus kt plus 1, and this is equal to L. I have to make y as a subject, so y can be written as L divided by 1 plus b e power minus kt, and this is my equation. This is the solution of that differential equation, and this is called logistic growth model equation. Thank you so much.